Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, thank you for the opportunity to present our paper at the second International Conference in Energy Storage Technology and Application 2022. My name is Rista Tristanti Kisdina from Electrocell Surya. Will present you our paper with title The Effect of Addition Chenodeoxycholic Acid or CDCA as a additive material to red dyes DN-F05 as a color sensitive substance in dye-sensitized solar cell. Let me start with explain our research background. Lately, Indonesia is a country located on the equator where Indonesia gets a lot of sunlight which can produce electrical energy by converting solar energy into electrical energy through photovoltaic solar cell named dye-sensitized solar cell or DSSC. One of the main components of DSSC is a dye, where the dye is a light-sensitive substance that will play a role in absorption of sunlight to exit proton which then produce electrical energy. In this study, the manufacturer of DSSC focused on using red dyes DN-F05, which is a type of metal complex sensitizer, which has the advantage of a cheap synthetic process, environmental friendly, and higher absorption coefficient, resulting in higher performance. In addition, we also focus on how the effect of adding chenodeoxycholic acid as an additive into dye. CDCA states that co-absorption materials that can increase the hydroxyl group and carboxyl group, which is effective in binding dye and increasing electron injection in TiO2, so it can improve the performance of DSSC. As we can see, materials that we will purchase from Solaronic and Dynamo Company. The process of making DSSC includes deposition of TiO2 paste into FTO as a working electrode and platinum paste into FTO, which has two holes on it, as a control electrode. Then both of the control electrodes were annealed at 450 degrees centigrade for 30 minutes. The next step is making DN-F05 with concentration 0.5 millimolar and various CDCA concentration was 5 millimolar, 7.5 millimolar, and 10 millimolars. Then dye and CDCA dissolve in 5 ml solvent of tert-butyl alcohol and acetonitrile with ratio 1:1. Then working electrode was soaked into the dye solution for 24 hours. Then assembly the working electrode with counter electrode using surlyn adhesive and press it with hot press. Electrolyte was injected into the hole and sealed with amosil. Here is the table of sample code name. The difference between them was on the amount of the concentrations of CDCA. With code name A, there are none of CDCA. In code name B, there are 5 millimolar CDCA. In code name C, there are 7.5 millimolar CDCA. In code name D, there are 10 millimolar CDCA. Here is the result of UV visible characterization. The maximum absorption of dye solution in UV light is at wavelength around here. The maximum absorption of dye solution in visible light is at wavelength around here. The absorption spectrum of the dye decreases while increasing the concentration of CDCA. The addition of more CDCA into the dye solution causes a decrease in the absorption spectrum. This happens because the addition of CDCA will cause competition between dye and CDCA molecules to occupy the TiO2 surface. Here is the result of FTIR spectral characterization. From the graphic, we can see that the TiO2 bonds are shown at wave number 418. TiO bonds were shown at wave number 628. Around here, CO bonds are shown at wave number 1293 around here, and OH bonds are shown at wave number 1600. CH bonds are shown at wave number 2932, stretching vibration of 3674, and 1172 show the presence of OH and CO functional groups. Around here, wherein the OH and CO functional groups act as active carriers of charge, which are responsible for better performance when exposed to solar illumination. Here the result of IV characterization. From the graphic we can conclude that addition of 7.5 mmol CDCA into dye with concentration 0.5 mmol shows the highest performance at 2.9% of efficiency with current density of 8.35 mA per square and open circuit voltage at 0.689 volts. The addition of CDCA with high concentration or 10 millimolar can reduce the performance of DSSC because CDCA can replace dye, and competition for light absorption occurs between dye and CDCA so that CDCA is able to reduce the amount of dye that binds the TiO2, which causes a decrease in DSSC performance. Here is the table of impedance parameters of our sample. As we can see, the series resistance of cell is also related to the process of electron transfer from dye to semiconductor and transfer of charge to opposite electrode, so that it affects field factor value, which affect the performance of the cell. The low value of the sheet resistance of device significantly contributes to the higher value of field factor. Meanwhile, chain resistance corresponds to charge recombination loss inside cell. Therefore, decrease in series resistance and increase in chain resistance is responsible for DSSC performance. Here is the result of same characterization of sample C here and sample A here. It's for 5000 magnification and it's for 1000 magnification. As we can see here, the surface of semiconductor layer without CDCA is smoother than surface of semiconductor layer with CDCA concentration here. The semiconductor layer with CDCA has more porous layer than semiconductor layer without addition of CDCA. Many small nanoparticles shown in figure relate to particle size of the TiO2 that we use. Here is the table of stability performance of sample that we make. It's for the first day, and this is for the second day of measurement, which is 30 days after the first measurement. From the table, it can be seen that the voltage increased while the currents decrease after 30 days. Slightly decrease in photovoltaic performance due to evaporation or leakage of electrolyte through the cover hole. However, the SSC performance slightly increased with the improvement around 1.26 different for over 30 days. It indicating good stability under ambient temperature. From the explanation before, we can conclude that DN-F05 with concentration 0.5 millimolar with 7.5 millimolar CDCA demonstrate of currency 8.35 mA per square with voltage around 0.689 volt with efficiency 2.9%, had the highest performance of DSSC, which is our sample C. The increase in DSSC performance was supported by UV phase and FTIR characterization, which showed that the addition of CDCA increased the light absorption of the OH and CO functional groups, where these functional groups act as active charge carriers, which could increase the efficiency of DSSC as well. Same characterization result which show that when given the addition of CDCA, it can be seen that the layer has more pores, so that more light is absorbed and produce large current and voltage. After 30 days under ambient temperature, DSSC maintained more than 104.77% of the initial efficiency. Thank you for the attention. Wassalamualaikum warahmatullahi wabarakatuh.